Okay, well, welcome everyone to the Ceph Developer Summit session on RBD. The link to the pad is in the chat and it's also shared on the screen. We have a rough list of items that we've come up with, but feel free to interrupt at any point or add your own to the pad or just bring something up in the middle of the meeting. That's fine. I'll start by just going over this one by one in the order that they are in the pad, and well, I suppose we can take it from there. The focus for the umbrella release, just as it was for the tentacle release, would be snapshot-based mirroring of consistency groups. This is a feature that is not upstream yet. It is being developed separately. We now have an integration branch for it. It used to, we had a particular PR that used to be kind of used as a reference point, but that is now replaced with that branch in the main Ceph repository, as opposed to someone's fork. We still expect that branch to be rebased, but it would be more rare, and this would be used as a driver for all of the kind of further pull requests for this feature would be targeting that branch. Originally, we had in the plan, there was a goal to have that merge to main. So in other words, upstream this feature in the umbrella release cycle. But if that's going to be shortened with the goal of returning to a stream cadence where upstream releases used to be cut sometime in April, which means that the freeze is sometime in January or early February at the latest. The upstreaming goal would be quite a stretch and maybe out of scope for Umbrella. But it's still noted here because pretty much any improvements that we make here improve the code and make it more viable for merging upstream. So that's just a general kind of note on this feature, and what follows as the rest is the list of items that are targeted for Umbrella. The very first one, and I guess the most important one, is support for adding images to a group when the group is enabled for mirroring. Currently, neither adding images to a group nor removing images from a group when it's enabled for mirroring is supported. We're referring to that limitation as static groups. So this would be a step towards dynamic groups, and we've been calling it semi-dynamic groups. The expectation is that adding images to a group is much more frequent than just expanding workload is more frequent than shrinking them. And the other reason is, which is actually much more important, is that it's simpler from the implementation perspective to deliver support for adding images to a group. With removing, there are a lot more edge cases that need to be handled, and the group replayer code, and in particular the way the group replayer interacts with the image replayer, that's just not ready for that, and more groundwork would be needed to make that happen. So the next item on the list is that exact work. Some of it will probably happen in the Umbrella release, but the support for fully dynamic groups is explicitly not in scope for Umbrella. And the reason this is important is because the only way to, like, if you really need to modify the the group membership, if you need to add an image or remove an image from a group, currently the only thing you can do is disable mirroring, make the change, and re-enable mirroring. But what that does is when mirroring is disabled, the group is the copy of the group on the secondary is cleaned up, both the group and all of the member images. Then you make a change, you re-enable mirroring, and the entire group is resynced from scratch. Not only this is a waste of resources, but what is much more critical is that for the duration of the sync, it's as if you had no disaster recovery enabled. It's as if there's no valid copy on the secondary. So if a disaster were to occur, there's nowhere to fail over to. So that's why it's at the top of the list. Going further down, the next item is continue rewriting mirror API handlers to allow for coordination between group level and image level tasks. Mirror API handlers here is calls like group promote, group demote, stuff like also adding an image to a group when it's supported for when it's supported in the mirroring scenario, removing an image from a group, resyncing the group, and so on. All of this has like all of these APIs except for enabling mirroring on the group has all of them have a common drawback today, where the way they're implemented is there is something done at the group level, and then, for example, taking promote as an example, the group would be, the groups, like there might be some checks done at the group level, but fundamentally the core of the the meat of the implementation is then that the group simply calls promote on individual images. It's done concurrently, but there is zero coordination there. So the group doesn't, if one of those calls for an individual image fails with some kind of error, we don't really know where it failed. All we know is that we got an error and this promote was, as a whole, unsuccessful. But we have very little potential for do anything other than just propagate the error and leave everything else to a user. So any kind of error recovery or quote unquote undo is very hard. Where we want to get with this is that promoting an individual image, there's it's a sequence of operations there that needs to happen, and the goal here is to make sure that these operations are performed still concurrently, but in a synchronized way, such that the first operation is performed on all of the images, and we move on to the second operation, and we move on to the third operation in that sequence. And that way, we would know exactly where something failed if we get an error, what can be done in terms of recovery from that, and we'll be able to deliver much more meaningful error messages to the user. And this is particularly important for force promote because force promote does it it gets to a point where it needs to do, like it may need to do it may need to do a rollback on one or more of those individual images, and that is a destructive operation because the data that was partially synced would just be destroyed. So for force promote, this sort of coordination is really important, so that we don't, in case of an earlier error, don't proceed and unnecessarily wipe out the results of the partial sync on the rest of the images in the group. Any questions so far? Right, then I'll proceed. The next item on the list is Raiders watch-based notifications for the group replayer. Currently, the group replayer doesn't have any sort of way of being notified. What it has instead is a timer, and every 5 seconds it is rescheduled. This interval is hard-coded; it's not even configurable. And every time every 5 seconds, the group replayer kind of main loop is rescheduled, and the group replayer attempts to list the group snapshots on the local group, list group snapshots on the remote group. This causes a bunch of traffic, a bunch of inter-cluster traffic, which can very well be unnecessary, especially if the snapshot scheduling interval is, let's say, an hour. The user ends up paying for the traffic if this is some kind of cloud setup. The interzone traffic is often the most expensive kind of traffic that you can have. It's minor in comparison to what would it take to sync the data, but still something that could be avoided. And then there are a bunch of implementation issues with this, some issues with locking, because the timer lock ends up being global, and because both the group replayer and the image replayer rely on it, the fact that there is this timer, or the fact that the group replayer needs to use this timer, leads to some complications and some workarounds for that in the code. So the idea is to reuse some of the code that is used for watching, for establishing a radius watch on the image header object, and therefore, this is how notifications for individual images are implemented. So the idea is to take this framework and apply it to groups as well, where the group header or just the group metadata object will be watched, and it should work similar to how it works for images. The next item on the list is introducing an equivalent of the mirror snapshot image state for groups, or rather for group snapshots. What this would allow us to do is capture more of a group state when the mirror group snapshot is taken. Right now, the only thing, or the only state that is captured kind of intrinsically, is the membership of the group at the time the snapshot is taken, because that is recorded in the actual group snapshot descriptor. But everything else, such as, for example, the name of the group, or the list of user snapshots on the group, or any other kind of metadata about the group, that is not captured. And that leads to problems when it comes to syncing user group snapshots. and also things like, for example, when the group on the primary is renamed, that rename is not supposed to propagate to the secondary unless a mirror group snapshot is taken. So the model is that all changes should be driven by mirror group snapshots, and that should be kind of the context for syncing not just the data, but also all of the metadata to the secondary. So that's the synchronization point. That's how it works for standalone images for the most part with snapshot-based mirroring. But that's currently not the case for groups, because the equivalent of this image state struct just doesn't exist. Nothing is captured when a mirror group snapshot is taken. So again, the idea is to take what is currently done for standalone images and apply it to groups with the goal of bettering the processing of user group snapshots. That's the most important one. But then also kind of smaller items such as handling renames correctly and other aspects of, we don't have much in terms of kind of group metadata yet, but that may be added in the future, and this kind of metadata would be captured by this by this mechanism as well. So I think that's mostly for this one. And the next is support for mirroring groups with images coming from different pools. So right now, putting mirroring aside for a moment, what is supported just for groups in general is images can come from different pools in the same cluster. But if the group is in the namespace, then all of those pools need to have the same namespace, and the namespace must match. So the namespace cannot be varied, and the group assumes that all of its images would be in the same namespace as the group itself, as the group header object. But images can come from different pools. Now with mirroring, even the aspect of different pools is restricted today, and with this item we want to eliminate that restriction. Prosana already has a patch for that, which is I think still in a work in progress state, but and depends on one other PR that is ready to be merged. But so this, I would expect this to land fairly soon, but it's still here on the list because it is an umbrella item. So that completes the list of topics that are kind of specific to snapshot-based mirroring of consistency groups. The rest is still related, but technically falls outside of that because it either touches something else in the rest of the RBD ecosystem, or I see that the group snapshot state removing item just got moved. I actually think that it is one of those kind of more generic items, because this new state would apply not just to mirror group snapshots, but also to user group snapshots. So it's fine to move it, but I think it needs to be de-indented because it is it is one of those more generic items. So I suppose I could start with that since it got moved. The problem that we have today is when the group snapshot is removed, or when it starts being removed, we don't record that, and therefore, if the process crashes or an error is raised, again coming from one of the snapshot remove calls on the individual member images, then we can't really do anything with that other than to just propagate that error, and then that snapshot actually ends up in a broken state, because if you picture a scenario where, let's say, the group had 3 member images, and we attempted to remove, so it had a bunch of group snapshots, each capturing those 3 member images. And then one of those snapshots was attempted to be removed, but that failed. And it failed, or the process crashed after it successfully removed the corresponding member image snapshots on 2 out of 3 images, but on the 3rd image, that snapshot still exists. This is at that point, this group snapshot is cannot be processed by the group replayer, for example, if this is a mirror group snapshot, or if this was a user group snapshot, then I suppose some of the CLI commands would fail because, again, because internally there would be an error raised for, there would be some kind of inOent error code coming from somewhere, because there was a snapshot ID recorded in the group snapshot for that image, or for those 2 images where the removing was successful, but those snapshots aren't there anymore physically. So introducing a kind of a transient state for that is what this item is about. We already have a state like that for when the snapshot is created, but it was for some reason missing for the removing side of the group snapshot lifecycle. This is not new. I mean, this goes back to 2016, maybe 2017, when support for group snapshots was introduced to LibRBD. But it's really, it's starting to really hurt now in the context of snapshot-based mirroring for consistency groups. So it has been prioritized, and would probably be also one of the first items to land for Umbrella. The next one on the list is staggering mirror replication schedules. This is so I guess just to expand on it, because the title itself might be somewhat confusing. So right now, the mirror snapshot scheduler that runs in the RBD support module in the Ceph manager. If you have, let's say, a bunch of images or a bunch of groups, it doesn't really matter which entity it is. Just if you have a bunch of schedules and all of their intervals are configured to, let's say, 1 hour, then currently the scheduler can very well schedule all of the snapshots for those entities, whether images or groups, at the top of the hour, so at the same time. It doesn't mean that the snapshots are then taken all at the same time, because then there is a throttle which allows for only a certain number of snapshots to be taken concurrently. But still, this means that if you look at the graph, you would see that there is a spike of activity somewhere close to to the top of the hour, and then if the if you don't have enough images or enough groups to for the system to be busy the entire hour, we've just taken those snapshots, which would likely be in heavily imbalanced and overloaded system. And then for the rest of the hour, it would be mostly idle, if you don't count the workload, of course, running on the primary cluster. So the idea here is to evenly distribute the scheduling of those snapshots. If we're talking about an hour, then across the hour, so that you have some number of images taken in the first quarter of the hour, some the same number in the second quarter, and so on. This is because the mirror snapshot scheduler is implemented as part of the RBD support module in the Ceph manager. This is a Python only thing. The rest of LibRBD would not be touched, and this is a fairly self-contained item. So someone who isn't even all that familiar with RBD could work on that, because this is completely isolated piece of code. It's not of high importance in my opinion, but this is something that keeps coming up in various discussions. So if we get someone who wants to work on that, then this is something that can land in Umbrella. Sunil?
Yeah, hi. So in the Stagger application, when you mentioned that number of images to be replicated, is there any way we can prioritize a subset of images to replicate? Because how it will decide when we have 100 images, which images has to take in the first hour and then second hour?
It's not going to be the second hour, the first hour, and the second hour. It would all be within the same hour. I mean, this doesn't change the fact that the moment when these snapshots would be taken, the fact that it would be spread out across the hour doesn't mean that we would be breaking the recovery point objective that the user has set. So if the user wants a snapshot to be taken on an hourly basis, meaning that they are, in case of a failover, they are prepared to lose up to an hour worth of changes to the image or to the group, then we cannot break that, right? So it's just that there might be a slight at the time mirroring is enabled, and the schedule is the schedule is set to a particular moment within an hour, that might be breached, but at that point in time. So it could be that for the first sync or for the first mirror snapshot, instead of an hour, it would be an hour and a half, but that would be just for the just when mirroring is enabled. After that initial step, it would still be like for each individual image or group, the snapshot would still be taken on an hourly basis. It's just not going to be at the top of the hour, but let's say 20 minutes into the hour for that particular group or image going forward, until the snapshots are kind of rehashed again, because if more groups or more images are enabled for mirroring, of course the scheduler would need to reconsider those kind of time, or I would call them time allocations, for lack of a better term, and kind of redistribute or rehash the schedules again across the hour. And we've been using an hour as an example, but of course you can have some images where the interval is as small as 5 minutes, and some images where the interval can be a day instead of an hour. That doesn't change anything with regards to the idea that it's just within that interval, whatever it is, for a particular set of images or groups that share the same interval. We want within that interval, we want some sort of even distribution instead of scheduling everything at the beginning of the interval as it's currently done in most cases.
Okay. So when we're doing also even distribution, the order of images, does it matter? Or if they think that user, this is a high priority image, they have to schedule according to the interval, like 5 minutes, something.
Well, again, I'm not like there's no really, if the user, I don't see where the notion of priority would even come in here, because if the user if the user has a bunch of images and all of them have the same interval, because that's how the user configured mirroring, then there's no way for even the user to tell which image is more important, right? Because they've configured the same interval there, and they're for sure, the scheduler cannot make arbitrary decisions about some kind of prioritization when it doesn't have any information. The only the only guarantee that the scheduler provides today and would continue to provide when this is implemented is that for an individual image or an individual group, there is at least one snapshot taken within the configured interval, so that you're never more than that interval behind in terms of syncing the delta that accumulated in that time frame. So the guarantee that we provide is that if you configure a recovery point objective of 1 hour, then that's what the scheduler would is supposed to respect, and it's just a question of not doing everything within the same kind of very short time frame, and then taking no mirror snapshots whatsoever for the rest of the hour, if we're again using the 1 hour interval as an example.
Okay. So yeah, got it. Means we are not considering the order of images. Yeah. Thank you.
All right. So moving on. The next two items are they apply to standalone images, and they were moved from Tentacle, and I think at least one of them is actually older than Tentacle. So these are kind of sync correctness issues for snapshot-based mirroring. Currently, snapshot-based mirroring of cloned images, you could say that it just doesn't work, because there are cases where the sync doesn't so the delta is calculated incorrectly, and then the sync, of course, has no chance of making the secondary image have the same data as the primary. This occurs when there is a copy up from the parent image to the clone, just as a result of the workload running on the clone and making changes to the clone on the primary. RBD Mirror Daemon is currently unable to correctly sync that to the secondary. So this is something that needs to be fixed, and really needs to be fixed instead of being bumped to the next release once again. Because this one is actually, from the point of view of the RBD mirroring, this is, this could be considered a data corruption, because the secondary is essentially corrupted from the user point of view. The primary is fine, so there's nothing bad happening there, but it's it just means that you don't have a valid copy on the secondary. So in case of a disaster, there's nowhere to fail over to. The second item is similar, but it's not a data corruption thing. It's just more of a kind of unnecessary space usage on the secondary sort of thing. There are cases where discards that are done on the primary are not propagated to the secondary correctly, and so that means for for a workload that for certain types of workloads, this can be a pretty big deal, because if the workload is like heavily expending, let's say generates a ton of files with some data in a file system, for example, like storing the results of some scientific experiment, and then after those results are analyzed, the whole thing is removed, and then the file system is trimmed with fstrim, for example. The space would be released on the primary. The underlying space at the RBD level would be released on the primary, but may not get released on the secondary, or at least not all of it would be released. And if again, this is just at the RBD level, but if you compare the the numbers that you get from Ceph df command or Ceph osddf command, then there would be quite a sizable difference there, and it it might prevent some use cases. Because you now have a ton of free space on the primary, but not so much on the secondary. There is a way to manually get around that, but it's it is involved. So again, we just need to sit down and fix this. And the fix there would actually be less involved than the fix for the copy up involving changes not getting synced. So it's actually should be easier to fix than the cloning issue. That applies to standalone images again, but by extension, since the group is comprised of member images, this also pops up in snapshot-based mirroring of consistency groups, both of these sync correctness issues. The next item on the list is a kind of a test thing. We would really benefit from a fuzzer for snapshot-based mirroring. And what is meant here is a tool that would generate some kind of workload, and then in the background perform various operations such as enabling mirroring, taking snapshots, promoting, demoting, simulating failovers, but all of that controlled so that it's not just so that it's not completely random, but takes into account what the workload is doing, takes into account the current state of the image or the current state of the group on the primary, validates that the state is as expected on the secondary, then performs an operation, waits for that operation to propagate, for example, right? Because some of those operations, you first need to wait for it to reach the secondary. So the tool that would have all of that knowledge baked into it, and then fuzz, so be semi-random in nature. with, of course, with some kind of seed, so that the so that the runs can be reproduced, but otherwise random, so that we weed out the all of the bugs that we still have, in particular in the group replayer and the interaction of the group replayer and the image replayer. But even for standalone image mirroring, I think fuzzer like that would discover some bugs that haven't been discovered yet. I'm fairly certain of that. Ideally, this would be usable both as a standalone Python script, so that we can run it in Jenkins, and this is a priority. But in the future, I see, this should be integrated as a pathology task as well, so that it can be run in real hardware and with the workload and RBD mirror daemons and the kind of the clusters themselves spread across several nodes. The standalone script would, of course, or at least the way I see it, it would be limited to vstart clusters, two vstart clusters running on the same node, and in order to, for example, kill the RBD mirror daemon, to test how the system recovers from such an event when it's killed, and then some time passes, the state of the group changes on the primary, and then it's restarted. The RBD mirror daemon is restarted on the secondary. This is this scenario is can be a source of quite some bugs, and in fact we are working on a couple of bug fixes that arise from exactly this scenario right now. So the standalone script would just do this on one node, but a pathology task would, of course, be capable of doing the same across multiple nodes, because pathology has means of tracking where each daemon is running, has means of remote execution, and controlling the lifetime of all of the daemons remotely, and so on. But the core, like the fuzzer itself, that logic can be shared, and it's just a matter of abstracting the interface for running commands and killing daemons and restarting daemons and so on, and implementing a kind of a local backend and then a pathology backend, and that would be the pathology task that I have in mind. Again, this is a Python-only thing, and no changes to the rest of RBD are expected here, or at least until it starts finding bugs. One challenge here might actually be that the fuzzer, like in order to test that the fuzzer is actually working, that it is capable of sustaining long rungs and it's doing the right thing with all of the permutations that it needs to go through, and that the randomization is working correctly. You need the RBD mirror daemon to cooperate, right? And so the worry is that the fuzzer would start finding bugs. RBD mirror daemon would very soon just get wedged or become completely uncooperative. So the person working on the fuzzer might run into that. But hopefully it's not good. And for groups, that might very well be the case. But hopefully for standalone images, that's not going to be that big of a problem. So yeah, that's that would be very cool to have, and something that would allow us to greatly increase confidence in both standalone image mirroring and group mirroring when it comes to the snapshot-based mode. Sunil?
Yes. So this fuzzer also, can we run the existing upstream test, or it requires separate scripts to write?
Well, it would be completely separate because it needs to be in full control of the system. So one thing that you can do today is do, for example, you can have like you can configure mirroring yourself, start a workload yourself, and then you can kind of quote unquote fuzz it manually by just saying, well, I'm going to go ahead and kill the RBD mirror daemon here right now, and then I'm going to wait for like a couple of minutes and then restart it, or I'm going to demote this group right now, right? This is something that you can kind of do today manually, but and some of this you could even do with kind of some kind of a side script running kind of alongside the workload. But in order to really make sense of it and fuzz it completely in a completely automated fashion, the fuzzer needs to be in full control of everything, including the workload. So it needs to be generating the workload itself, because if it needs if it chooses, like if the next operation that it chooses to do randomly is, let's say, a demotion on the primary, well, in order for that to happen, the workload needs to be stopped. Otherwise, you can't demote. And then if the natural, then from that point, you can either re-promote, right? So basically cancel the demotion, or go and promote on the secondary after waiting for the after waiting for the demotion to propagate. Right? All of this logic, like, it needs to be encoded in the fuzzer, and there's really not a way to do it somehow kind of on the side when there is some other workload running on the system, and the fuzzer is not in full control of those images or those groups that it's working with.
Okay, yeah, thanks.
Right. Any other questions? The next two items on the list are these are kind of really old ones, and this is more of a wish list. So probably not in scope for Umbrella, but it is this is a long-standing issue that goes back to the introduction of snapshot-based mirroring, where the force promote is there were some design mistakes as well as deep down implementation issues, which basically mean that the force promote is not really forced. It has, in order for the image or a group to be force promoted immediately, there is a bunch of preconditions that need to be met. And the easiest way to achieve that is actually to just scale down, or in other words, scale the RBD mirror daemon before this command is run, before force promote is initiated. This is, of course, something that the user needs to keep in mind if there is some kind of orchestration system. For example, in Kubernetes, this is Ceph CSI. This needs to be automated. All sorts of issues kind of spawn up there, but it is how it works today. And there are some improvements that could be made. Some gradual improvements that could be made to make this kind of slightly better, and that's why I've added this to. That's why it's here on the list for Umbrella, because we could at least work towards that. But I don't think it's feasible to resolve this issue in full in the scope of the Umbrella release. But these two items are, they're, again, just more as a wish list sort of thing. And with that, the section on mirroring is concluded. We have two more. There are a couple of things on the CLI, and then a couple of items on the kernel client side. So So on the CLI, the first item is we have the RBD DU. This is short for disk usage command, which unfortunately does not display the usage for non-user snapshots, in particular mirror snapshots, and also group snapshots, or the snapshots that correspond to a group snapshot on the individual images. Those are completely, like, those snapshots don't even show up in the output. They are, it's as if it's as if they didn't exist as far as the RBD DU command is concerned. And prior to the Tentacle release, this was the case because we didn't even have an API for that would allow computing disk usage, that would allow coming up with a number, or at least an estimate, because the RBDU command, it's more of a kind of upper bound estimate than an actual disk usage. But we didn't even have a way of doing that for non-user snapshots until the Tentacle release. Now that is in place. It was implemented by DNA. But the part where RBD disk usage command gets changed to take advantage of that was broken out of the original tracker ticket, and it would be good to get to it and address it in the umbrella release, because with more and more RBD mirroring use in various different setups, both in Kubernetes and now going forward also with standalone Ceph. The fact that mirror snapshots aren't included in the disk usage calculations is quite a gap. Ordinarily, that wouldn't be that big of a deal, because mirror snapshots are short-lived, right? Mirror snapshot gets taken, gets synced, and then once the next mirror snapshot is taken, the previous one is recycled. But in case of in case mirroring, there's an issue with mirroring, like if there is, for example, a connectivity issue between the clusters, then in that case, mirror snapshots can accumulate. And then you do want to know how many there are, and how many there are you can determine from a different output, but how much space has been consumed unnecessarily, or at least how much space will be freed up once connectivity is reestablished, for example. So once mirroring gets out of this kind of backed up state, there is no way to determine that today. So that's that.
Ilya here. So for each of the mirror snapshot, space will be displayed, like whatever the usage, or it will be combined for all.
No, it will be listed for each mirror snapshot, and then the RBD disk usage command also computes the total.
Okay.
So it would be exactly like if you know how it works and kind of what is displayed for user snapshots today, then
Yes.
it would work the same way for non-user snapshots. This includes mirror snapshots and the group snapshots that correspond to a snapshot at the group level. It would work the same way, but the output would probably change. So it would probably not be. It may not look exactly the same, because there are some concerns with these snapshots technically belonging to different namespaces. But there is a mirror namespace, there is a group namespace, there is a user namespace as far as snapshots are concerned. So, and because currently we only display user snapshots, the namespace isn't even mentioned anywhere. So the format of the output would likely change. But the idea would be the same. There would be an entry per snapshot, and then at the bottom, a total would be computed.
Yeah, then fine. Yeah, thank you.
All right, and the next item there is consistent timestamps. So currently across the RBD CLI, across the different commands, we have a mix of different output formats. So the timestamps are output in different formats. Sometimes it's the format that is more amenable to parsing by a script, and sometimes it's the most human readable format possible. But what is more important and more confusing is that it also ends up being a mix of a local time zone and a UTC time zone. In particular, this pops up with regards to the mirror snapshot scheduler. And the reason there is that the RBD CLI tool, this would be a tool that is run, it can be run anywhere on any node, right? But when the same, when the RBD CLI tool is used to query something about the mirror snapshot schedule, then what it actually does is it sends the command to the manager daemon, and gets the output from the manager daemon, and then simply dumps it out to the screen. And since the manager daemon, it's part of the cluster, it runs on a node, like most likely in some kind of container. And that tends to be like the cluster nodes tend to be configured with the UTC time zone, and then the user, the user is left wondering, because if they do something, if they run, for example, RBD snap ls command, then that lists the timestamps on those snapshots are with the local time zone corresponding to to that node. But then when they run on the same node, RBD mirror snapshot list command, or I'm sorry, RBD mirror snapshot schedule list command, then that suddenly displays timestamps in UTC, or whatever time zone the manager is running with. So that's that was highlighted as a problem, and I was actually wondering what is done, for example, in Ceph, because Ceph has the same kind of split where some of the commands are local, and then a bunch of commands are served by the various Ceph related modules running inside of the manager. So I don't think this problem is unique to RBD, or maybe Ceph folks have already handled it. So this might actually be a good topic for the Subdeveloper Monthly session, because it is concerns input from other components and other teams would be useful. But again, just something that came up, and I'm not sure if we'll be addressing it in umbrella release. If the fix is simple, if, for example, if we make a decision to revert to UTC time zones everywhere, then that's a simple patch. But if the approach, if it's the reverse, if we decide that displaying everything using a local time zone is better, then we would need to, I suppose, tell the manager to, generate the output that it generates, using a past time zone. So the interface between the CLI tool and the manager would need to change. So the manager command would need to change. It would need an additional parameter, and that's a bigger change. So again, I think this is a good topic for the Ceph Developer Monthly, and I'll make sure to add it there for the next EMEA session. That concludes the list of items. For the kernel client, there are a couple of items for the kernel client, but they're just copied from the Tentacle release, and they're nearly done, but aren't merged yet because that work was deprioritized. But since they're nearly done, I'm hoping that in the next few months, certainly within the umbrella cycle, they would get upstreamed and be basically claimed complete. They aren't even specific to RBD. Both the upmap read balancer and the crush multi-step retry rules, these are Rados features, but it is me who's working on these, and they were included, and they affect the RBD kernel client, of course, as well as the CephFS kernel client. And I've included them here just because, nominally it's the RBD team that is working on them. We're slightly out of time, but I think Sunil has his hand raised. Please go ahead.
Right. When we are mentioning about the different time zone for the scheduler, is there any, can we support also for user to add the different time zone when they are adding snapshot schedule?
Well, the user doesn't really configure any kind of time when they add a schedule. All they do is they configure an interval, right? So the command that the user would run would typically be, some command, and then they would say, for example, pass an image name, and then something like 5 minutes or 1 hour or 1 day. It's an interval. It's not the not really a timestamp. Now, the scheduler actually does have, so the command for adding a schedule actually does have a start time argument, which is or could be interpreted as a timestamp, but it's not really. It is very confusing as to what it does, and it's not really it's not really a timestamp in the in the sense of it's more of an offset from an epoch, from a Unix epoch timestamp. So January 1st, 1970. It is not documented, and or maybe it could be mentioned somewhere, but it's not really documented how it works, and I'm not aware of anyone using it. So I think we can basically ignore it. The concern here for this, for this item, is really just the output. So when you list the schedules, or even it's not even when you list the schedules, but it is when you list the there is RBD mirrors snapshot scheduler status command, which lists the all of the images and all of the groups that the scheduler is kind of aware of, that the scheduler is tracking. And then it lists there is a column with the next, with the timestamp for the next snapshot. So when the next mirror snapshot would be taken for that particular image or group. That is where the problem arises, because you look at that output. And if there is a difference, like if, for example, that output is in UTC because the manager daemon is running in a container and that's UTC on some node that is considered to be part of the cluster and is also configured in UTC, but you're running this command locally on another side of the continent, then the difference can be many hours. And you look at the RBD snapls command, you see that the most recent snapshot was taken, let's say 10 minutes ago, and you know that your scheduling interval is 1 hour. But then you look at this status output for the scheduler, and it tells you that the next snapshot is going to be taken 3 hours later or 4 hours later. That's where the user gets confused, because it is obviously confusing if you don't know that the issue is with time zones and timestamps.
So it's good for user to avoid those time zones.
Well, ideally, we should either part of the problem is that it's not even annotated. So the way the output is formatted when by the status command for the scheduler, there is no annotation there whatsoever. So the user can't really tell which time zone it's which time zone it is. So that might be also kind of an easy way to at least kind of a partial, and I wouldn't call it a fix, but just to eliminate at least some of the confusion is to just add that annotation there. So change the format in which these timestamps are displayed by the status command in the scheduler. But still, asking the user to essentially do the math in their head when they look at the RBD SnapLS output and see that that output is in let's say is in Pacific time, and the output on the coming from the manager is in UTC. Having them do that math, even if the time zone annotations are there, is that's not a good user experience. So the actual fix in my mind would be to either make it to somehow get to a point where we would be consistent, and whether it is converge on local timestamps or converge on UTC timestamps. Opinions can vary here, but what matters is that it is consistent, so that either way the user doesn't need to do time zone math in their head on the fly when they see the output of any of these commands.
Yeah, that solution is really good. Yeah, thanks. Really.
Well, I think that's all. That's all there is on the list. Is there anything else that anyone wants to bring up? Right. Well, there was some suggestion or kind of a question raised offline, and it was about. So the question was whether we would be deprecating anything in the umbrella release, because discussing it and then announcing it early would obviously be a good thing to do, but honestly, nothing comes to mind. We do have some kind of some areas of RBD that are kind of somewhat unmaintained, or even you could say completely unmaintained, and therefore could be deprecated. But this is not new with umbrella release. So this kind of trail of stuff that still builds and to some extent works, but no one has planning on fixing the known issues there and many more unknown issues. That like there are definitely parts of librd like that, or like librd plugins like that. But again, that's not new with Umbrella, so I'm not sure. And certainly nothing like that was kind of planned in advance. So I don't have anything to kind of mention here. One thing that kind of happened in the Tentacle release that was long overdue is we've switched the default for the RBD device map command for the kernel driver for kernel RBD. It now defaults to Messenger 2 instead of Messenger 1. But that doesn't mean that this is something that would just allow for Messenger 1 to be deprecated sometime later. So definitely not in the Umbrella release, and this deprecation would be coming from the Raiders side. This is not an RBD decision, but obviously we couldn't deprecate. We couldn't even announce deprecation when there was a major command that still defaults to Messenger 1. That was an omission on our part. We do have orchestration systems. So, for example, Ceph CSI has long switched to Messenger 2. It was just kind of the bare command that I guess is still used by users who just have kind of plain old bash scripts and don't specify every single option explicitly. Such a bare command was still defaulting to Messenger 1. That was corrected in Tentacle. And that sets the path for eventually deprecating Messenger 1. But nothing like that comes to mind for the Umbrella release right now. So I'll ask one more time. If there are any other topics that anyone wants to raise, and if not, we can adjourn. Thanks, everyone. Have a good rest of your day. And thanks for attending the RBD session.
Thank you.
Thank you.